In this video, we will walk through the physics process function, understand how the agent's rewards are generated, and learn how a replay buffer can be used to train the agent. The physics process function is called for every frame generated by the game. It is called many times per second to update the agent. Delta is the amount of time since the last frame was drawn in seconds. Apply gravity puts a downward force on the agent if it is not touching the ground. Timers are updated, and the agent's position, along with the nearest coin's position, are collected to be used later. Next, the execute action function is called to move the agent based on its last chosen action. The execute action function checks to see if the agent is on the ground. If it is, current jumps is reset to 0. This variable makes sure the agent can't continue jumping after a double jump without touching the ground first. The move toward function is used to slow down the agent if it doesn't move left or right. Now, a force is applied to the agent based on the action that was passed into this function. 0 moves right, 1 moves left, and 2 calls the jump function. The jump function is where current jumps is checked to see if the agent is allowed to jump. If it is, the force is applied and current jumps is increased by 1. Lines 106 through 108 are used to make sure new actions aren't chosen more frequently than the decision interval. Currently, the decision interval is set to 0.2 seconds, which means a new action won't be chosen until the last action has been executed for at least 0.2 seconds. If there is a previous state and a previous action, we get the current state, the current distance between the agent and the nearest coin, and the reward for the previous move. The getReward function checks to see if a coin was collected during the last move. If it was, a reward is generated by subtracting 0.5 from 100 for each second the agent took. If a coin wasn't collected, a reward or penalty will be calculated based on whether the agent moved closer or farther away from the nearest coin. This value is then multiplied by 0.01 and clamped, so it will be at most 1 and at least negative 0.2. This helps to keep updates small so that one update doesn't have a huge impact on the agent's policy. It is beneficial for the agent to learn from many small updates, since more experiences will help shape the policy. Small updates also allow the agent to adapt to changes more easily. After clamping, the reward is decreased by a small amount since the coin was not collected. The goal of this reward function is to encourage the agent to move toward the nearest coin and collect it quickly, while discouraging the agent from moving away or taking too much time. After getting the reward, the isDone function is called to see if the current episode should be ended. If the agent has taken too long to collect a coin, done is set to true, and the agent receives a penalty for not collecting all the coins. Next, the store experience function is called. The store experience function collects the information needed to train the agent. This information is kept in a replay buffer. When the agent is trained, the sample batch function returns a random sample from the replay buffer to update the agent. Taking a sample of past experiences can be advantageous since the agent can learn from its actions more than once. The replay buffer also allows the agent to use a combination of newer and older experiences, which forces it to learn gradually. This gradual learning, similar to the low reward values, helps the agent learn general strategies so it can adapt to changes. The current state and distance become the previous values for the next time this function is called. If done was set to true on line 119, or all the coins have been collected, the episode ends. First, the epsilon value used by the epsilon greedy algorithm is decreased so that fewer random moves will be chosen. Next, important values are printed and added to a file to help with debugging. Then the agent and coins are reset. If the agent is not done, the agent might train if enough experiences have been gained since the last time it was trained. The target network's weights may also be updated to the Q network's weights if enough steps have passed. If there wasn't a previous state or a previous action, the previous state and distances are set to their current values to be used the next time this function is called. Then a new action is chosen using the choosEaction function. The choosEaction function starts by generating a random number and compares it to epsilon. If the number is above the epsilon value, a random action is chosen and returned. This helps the agent explore more options without getting stuck with a policy that is not optimal. If the number is above the epsilon value, the next action is chosen from policy. The Q network generates Q values for the current state, then the largest Q value is determined, and every action with that largest Q value is put in a list of best actions. A random action from the actions with the highest Q values is chosen and returned. If Q values can't be generated for the current state, a random action is returned. The epsilon greedy strategy used for this function was explained in further detail in our Q learning overview video. Thank you for watching. I hope this video was helpful.